Okay, today you are going to be doing a virtual earthquake lab. Once you get to the website in the computer lab, this is what it looks like, and we're going to click Execute Virtual Earthquake. Now I know this is kind of hard to read, but I didn't want you to miss me entirely, so I thought I would make you a video so you could hear my lovely voice and you wouldn't be too sad. So the first thing that this is going to have us do is it's going to show you some information about the seismograph. So it's showing you the P wave arrival time is actually where the wave first begins. The S wave arrival time is where the S wave first begins. And when you're measuring this SP interval, you have to measure from start to start, and that's really important. You have to look at the scale down here and decide how many seconds did it take. There's a second part that asks you to measure the amplitude. So here they're showing you that the amplitude is the height of the wave from the center to the top, and you're going to be measuring the highest point. All of this information is on the website, so please make sure that you use it, especially the pictures, and read through as needed. I'm going to show you how to do the San Francisco area. When you go to the computer lab, you need to come down here and select Japan. Japan is the required seismograph that you have to make, but you can also do Southern California and Mexico when you finish for some bonus points. So we're going to leave this on San Francisco for right now for the demonstration. You're going to click Submit. Then it gives you some other information. It's going to show you where the seismograph stations are, and this is going to show you specifically how to measure the interval. So again, we are measuring from beginning to beginning, and you are going to be subtracting. So this is showing you that this takes about 36 seconds, and we're going to be entering those numbers. So here's my first set, and when I measure these, I get 49 seconds. And feel free to pause the video if you want to have the students come up and make marks on the screen, or whatever needs to happen for them to understand how to measure. Pay close attention to this scale at the bottom because it's not the same for every graph that you'll read. The second one for Elko is 72 seconds. And the last one, because remember we need 3 stations, is 63 seconds. Now, if you're not close enough, it's going to tell you that your measurements are not accurate enough, and it's going to send you back to fix them. So be cautious, but don't spend forever. Zoom in to the screen as needed. So I'm going to click Convert, and then it wants us to now do some work to determine the earthquake distance in kilometers. So what I have to do is read this graph that I've basically just made with the last set of information. It wants to know in Eureka at 49 seconds, how many kilometers is that? So I have to read up here on the graph 49 seconds, trace across, and that is about 478 kilometers. And you're going to do that for each one and enter your data. Again, if you're not accurate enough, it's going to tell you that. So this says excellent work. Obviously, I was prepared to put these numbers in. If this does not say excellent work, it's going to send you back and have you remeasure. That's okay. Take your time, go back and try to fix them. And remember, it doesn't mean that all of them are wrong. Just double check. So what we're going to do now is we're going to try to figure out where exactly is the epicenter of this earthquake. So the next thing that we have to measure is the magnitude. And this is where you have to measure the amplitude, like what we talked about. So it's going to have you measure from the center of the wave to the tallest point. And that doesn't matter where it is in relation to arrival time versus where it ends, but we're just measuring the tallest point. And this is of the S wave, so make sure that you're on the second one. And remember, this is all on your screen, so it's going to show you step by step what to do. This is showing you the magnitude, or the Richter scale, and how it works. So this is going to connect the distances that we entered, and it's going to trace across to the amplitude, and it's going to show where all of these cross is the magnitude. So the next thing we have to do is we have to enter the amplitude so that that Richter scale will work for us. And I'm going to measure from the center where it says 0 to this highest peak. And we're going to do that with each one. So again, I'm just going to go ahead and enter the numbers, but you'll have to calculate them by reading the graph. And then you click submit. And then it has traced these lines. This is the data that we have provided, kilometers across to that amplitude that we just measured. And what you're going to need to do is get really close. Where all three of these cross, it looks like 7.1. That is the magnitude on the Richter scale. And this is what scientists really do. This is why we need 3 seismograph stations. So I'm going to put in 7.1 and I'm going to confirm to make sure that that is correct. And it is. If your data, again, for the amplitude is not accurate, you will have to go back and recalculate those until it's accepted. Once it's accepted, you can either show the sub that you have completed that part, or you can print and attach your certificate.